Right. I thought we'd look at a few examples of problems where you'll be considering one-sided limits or continuity. We're going to look at absolute value problems first. As always, you should, when you're finding a limit, try direct substitution. So as I look at putting 10 in for my numerator, I would have absolute value of 10 minus 10, which is 0. And then denominator 10 minus 10, 0. I get that indeterminate 0 over 0. So I have to try something else. So with absolute values, what you need to be doing is to remove that absolute value. So to do that, you want to get to the correct branch. Now, when I talk about branches of an absolute value, remember, there's a positive branch. And for that branch, we just use what's inside the absolute value, just use that expression. And then the negative branch, where we do the negative of that expression inside the absolute value. And you would just want to leave it looking like that with the negative and then the parentheses. So on problem number 1, we are doing the x approaching 10 from the right. So we need to remove the absolute value using the positive branch. And so we'll be looking at the limit as, the limit as x approaches 10 from the right of x minus 10, the positive branch, removing the absolute value, over x minus 10. Well, notice that those are common factors, so you can cancel. Now, when you cancel, it's like division. So x minus 10 divided by itself would give you a 1. And so you're really doing the limit as x approaches 10 from the right of 1. And the value of a limit for a constant is just that constant. And so your limit, I'm going to go ahead and use the letter L. Your limit for that problem is equal to 1. So the limit as x approaches 10 from the right of the absolute value of x minus 10 over x minus 10 is 1. And so I'd like to compare that to problem number 2, the limit as x approaches 10, this time from the left. So just like we had at the first, if we did the direct substitution, we would get 0 over 0. So that fails, and we have to remove the absolute value as our next strategy. But this time we're looking at the limit as x approaches 10 from the left. So from the left, we want to use the negative branch, the negative slope, the negative branch of that x minus 10. And so we would have, removing the absolute value now, the negative of the quantity x minus 10 as our numerator. Our denominator is x minus 10. And once again, we can simplify by canceling, leaving a 1, so that we are actually doing the limit as x approaches 10 from the left, but I want you to look at the fact that I have a negative on this one. So it actually isn't 1, it's negative 1. Negative 1 divided by 1, and so this is negative 1, and therefore our limit is negative 1. Now, I don't have another problem that goes with this, but if I asked you the limit as x approaches 10, and I did not put it from the left or the right, but just as x approaches 10 of this function, the absolute value of x minus 10 over x minus 10, I hope that you would see that since from the left I got an answer of 1, and from the right I got an answer of -1, that the limit as x approaches 10 does not exist. That limit would not exist. And then our second problem, or set of problems that I'd like to look at, numbers 3 and 4, have to do with greatest integer functions. Now, there's no algebraic way to look at greatest integer functions. These limits have to be investigated using numerical values, using a table. And something that you need to know about greatest integer functions is that they are step functions. So you are not interested as much in what is happening at the C value. You are interested in what is happening very close to the C value. So we're going to investigate, starting with 2 from the left. I'm going to choose an x value that is close to 2, but is left of 2. So in other words, smaller than 2. So I'm going to use x equals 1.999. And so substituting in 2 times 1.999 minus the greatest integer function of 1.999. Well, 2 times 1.999 is essentially going to be 4. It isn't quite 4. It approximates to 4. It's essentially 2 times 2 minus, and then the greatest integer function of 1.999 is, remember, those always round down. So 1.999 does not round to 2 with the greatest integer function. It rounds down. And so that would be 1. And so this limit is 3. So the greatest integer function, remember, rounds down. That limit is 3. If we take a look at what happens on number 4, when we look at 2 from the right, so again, we have a greatest integer function. We have to investigate this one numerically rather than algebraically. So I'm going to use a number that is to the right or bigger than 2, but very close to 2. So I'll do 2 times 2.001. That's a number to the right of 2. I'll put that in for my x's. And I'm trying to do this without a calculator. So I am going to estimate, because I'm looking at what is my value becoming. So 2 times 2.001 is very close to 4. So that's becoming 4 minus, and then my greatest integer function takes 2.001 and rounds it down to 2. So this is 4 minus 2, and the limit as x approaches 2 from the right is 2. And so as you look at this one, again, I don't have a separate question, but if I asked you the limit as x approaches just 2 of this function, and I'm just going to put f of x for this, so I don't have room. Again, since they have different answers, that limit does not exist. So those are a couple of functions that I think you'll see fairly often, and I would like for you to know how to investigate those. So with absolute value, you can do some algebra. In fact, you need to remove the absolute value and see what's going on. With greatest integer functions, You have to investigate those numerically. You can create a table, or you can just work with a number that's very, very close to the C value that you have, and find out what's happening to the values. Now I'm going to move on to number 5. And I know, students, so you were probably copying all this down while I was talking to you. But I hope that you'll pay attention to what we need to do and what you're being asked on this. It says to find any x values at which f is not continuous and identify the discontinuities as removable or non-removable. And since I have such a hard time writing, I thought that I would try to speed things up by having a few things already written down for you. But I still want you to pay attention to what's happening. So on this problem, now notice that we're not asked to do a limit. We're just going to look at this function. So when I see that x minus 6 over x squared minus 36, I've got a rational function. So I'm going to be thinking about the denominator, and are there any values of x that would cause me to have a 0 in that denominator? Well, that would be a lot easier to look at if I took that denominator and factored it. So that's a difference of 2 squares. I'm going to factor it into x minus 6 and x plus 6. And I'm going to notice that I can simplify, or maybe you might think remove, the x minus 6 factor, but I cannot remove or simplify the x plus 6 factor. Now, I'm still going to deal with the fact that I had 2 factors. So one of my factors in the denominator is x minus 6. If I set that equal to 0, I get that x equals 6. Now, that was my factor that I was able to remove. And then my, sorry about that, my other factor is x plus 6. If I set that equal to 0, I get x equals negative 6. That was what I was not able to remove. So f is not continuous at, and I'd like for you to use the x equals. So x equals 6 and x equals negative 6. The types of discontinuities, I had a removable discontinuity at x equals 6. And then just as a little added bonus, I'm going to talk to you about the graph. There would be a hole in the graph at x equals 6. That's the type of graph you have for a removable discontinuity. And then the other one is a non-removable discontinuity. And that occurs at the other factor solved for 0. So x equals negative 6. And for that graph, there would be a vertical asymptote. And that would occur at x equals negative 6. And I thought of another question that you could be asked. You could be asked to give the intervals where the graph is continuous. So I'm going to try to squeeze that in right here. It would be continuous on, and I'm not sure I can fit all this in. Now we would start from the far left, so negative infinity to our first break, negative 6, union with, and then between the 2 breaks, negative 6 to 6, and then union with 6 to infinity. So hopefully you can see that. I think that could be another way that you could be asked about discontinuities. So these are your notes that go with homework 7, and I hope you are able to use these to help you out with that homework.